This is question number 3 on homework 5 for chapter 5. So here we provided with different annuities if you click on this data table. And what's good about the current version of the MATLAB is that you can actually copy this into spreadsheet by clicking on this icon. So that makes the calculation even more convenient. So the question here is that this lady, Licky, could earn 9% on her money by placing in a savings account. Should she place it instead in any of the annuities? Which ones, if any? So part A is what rate of return could Licky earn on her money if she places it in annuity A with $6,500 payments per year and 20 years duration. So if we click on this, first, as we said, we can just copy this, open this in Excel, and then we can see that each of the annuities here has a so this is the data table with information on each of the annuities. We have 3 annuities here, A, B, and C. Each of them requires some initial payment. So this is like our initial investment. And then we have each year the annual payment and the duration of the annuities. So this is like our investment, and this is like our return in terms of the cash flows. So the question here is asking us what is the return on annuity A. So this return here, if we think about compounding, then this is return because this is my investment. Then after I put the money into this annuity, and then it starts to earn money for me, similar to when I put money into the, for example, into the stock market, and then when the stock price rises, then I can get some return from there. So similar idea, but the difference here is that instead of having just one single price fixed to some stock, here we're actually getting some annual payment for a specified number of years. But when we speak of compounding, this is the return. But then when we speak of the discounting, then this same return becomes the discount rate. So that's how we can figure out the return from each of the annuities here. So how do we do that? Basically, in terms of the discount rate, this is for annuity A, the initial investment here should be the present value. And then this is the annuity payment. And then this is the number of annuity payments. So basically, we need to calculate the interest rate. Interest rate is when we check the formula for the annuities, basically we need this R, right? That R is the interest rate, is also the discount rate, and as we said, in terms of compounding, that also becomes the rate of return. So this is the interest rate, and this is the return, and this is the discount rate. So they are all referring to the same number. So interest rate, annuity A, and there's a function within Excel which we can very easily use to figure out the interest rate, and that is actually the rate function equals rate and open. So when you open this this function, you can see that there are different arguments here. The first one is NPER. This refers to the number of payments, number of time periods. In this case, it's this cell value. Just put this D2 here, which is 20. And going forward, the second argument here is PMT. This refers to the payment. And then let's continue. The third one is the present value. PV is the present value. What must the rule of the Excel and also the financial calculators is that we need to keep these two streams of cash flows to be of opposite signs. What that means is that if we want to use a positive payment, annuity payment, then we have to have a negative present value. And then we can also switch signs for both, which means that we can have negative annuity payments, but then we need to have positive present value. So that's the rule here. So now I want to use negative payment. So I just add a negative sign in front of this this payment amount here, and then I can just use for the third PV value, I can just use directly the present value. So, and then you can see there are also other arguments here, but you can see this square, this brackets here means that they are optional. So if we don't put any number here, they just by their default. And for example, the FV refers to the future value. Here we don't have any future value because that refers to if there's any future investment. I mean, in this context, if there's any future value, that means if there's any on some future date, if we put some further money into this annuity. So, but in this case, there's nothing like that. And the type basically means it's end of the year or the beginning of the year convention. And guess value is like those Excel basically uses try and error to figure out the discount rate. Hence, the guess value means that the starting value of this trial and error process. And I believe if you don't put anything there, that Excel will start from 10% and do some trial and error until it converges to the true rate. So here I don't want to bother with all those three inputs. So I just close this function here, and it gives me a number 9%. But then we need to be careful because then we need to go back and check the rounding requirement. Here it's rounded to percent and rounded to 2 decimal places. So this 9% doesn't mean it's exactly 9%. It may be, for example, 8.6%, but it's rounded to no decimal place. That's the final result. So that's one thing we need to be very, very careful when we use Excel. And what we can do is to right-click on the cell and then choose Format Cells, and then choose Percentage. And then you can see as I said, the reason we got 9% is because we kept 0 decimal places. But then we want to change this to be consistent with the rounding requirement by increasing this to be 2. So then you can see it becomes 8.84%. So that's the answer for part A, 8.84%. And then I can check my answer. And then we can continue that, continue for the next part of this question. If Nikki could earn 9% on her money by placing into a savings account, should she place it instead in annuity? So obviously here, since the annuity gives a return of only 8.84%, but this alternative savings account actually can give her 9%. So obviously she should not place her money in annuity A because the expected rate of return on the annuity is smaller than the one on the savings account. And then we can continue for, I believe this is for annuity B. We do a similar calculation for the rate of return. Actually, that here we can show the another benefit of using Excel is that it, because these numbers are annuity A, well, I mean these numbers for annuity A and B and C, they are placed in a very orderly fashion. So what I can do here is actually to directly drag the cell to the other annuities. Now you can see the rate of return for the other annuities actually can automatically be calculated, and you can click on this cell here and find out it equals rate, and D3, which means this is the number of annuity payments for annuity B, and negative stage 3, that's the annuity payment, the B3, that's the initial payment. So and then this also the format will also follow the format in for this annuity A. So that's also one very good benefit of using Excel. 7.98%. Just copy that number back. 7.98%. And check my answer. We're done. So obviously, this is also lower than the alternative savings account return. Hence, I guess no, Nikki should not place her money in annuity B because return is smaller, right? So, and let's continue. Actually, we already did the calculation for annuity C. Just copy the number, basically, 9.63%. And now the preference will change because you can see that here the return is higher than 9%. So yes, Nikki should place her money in annuity C because return on annuity is greater than the one on the savings account. So, and then I think we're done with this question.